Hi, Algebra 1. We already went through quite a bit of this, but we're going to go back through it on, I'm going to be on page 115. You might already have the notes for it, but just let's double check, make sure that the terms that I'm using are consistent with what you have done. Okay, this problem looks very similar to the one that was on the test, and I worked it out the other day. So our independent variable is going to be the miles. Our dependent variable is going to be the cost. You know, how much something costs. In this case, it's an Uber ride. So if we do 3 miles, I'm going to take my equation up above. And what I'm going to do is I'm going to go 0.40 times 3 plus 8. And if I multiply this together, that comes out to 1.20 plus 8.00. So this means that our Uber ride is going to cost $9.20. So going 3 miles for $9.20, I don't know if that's a good price or not for Uber, but let's go with it. And then it says if you live 10 miles from your destination, how much is it going to cost? So I'm going to take the same equation from above. 0.40, and we're going to plug 10 in because we want 10 miles plus 8.00. And again, this just came from the equation up here. So this is going to give me 4 plus 8, which this is going to cost us $12 to go 10 miles. And then we want to know, if I have $20, how far can I go? Oops, I don't know why that happened. So 20 is going to go on for this. And then I'm going to solve the equation. I'm going to subtract 8 from both sides. That gives me 12 equals 0.40x. Divide both sides by 0.40, so you'd want to use a calculator on this. So on my calculator, I'm going to go 12 divided by 0.4, 12 divided by 0.40, and that comes out to 30. And this means that if you had $20, you can go 30 miles. Let's not worry about the domain and the range of these at this point. I think we might have done it the other day, but let's not worry about it. And then what does 0.40 represent in the context of this mile in our problem? So remember our original equation was c at x equals 0.40x plus 8.00. So this means the 0.40 means they're going to charge you 40 cents per mile. And then the $8, what does this mean? This means that this is an automatic charge. So if you called the company to come pick you up, they're going to charge you $8 just to have the car get to you, or the truck, or whatever type they're going to take you on the Uber drive, okay? I'm not going to worry about these. And then this is called slope-intercept form of a linear equation. Okay, f at x. Remember, f at x is another word for saying y. So if I had f at x equals mx plus b, that means that it's also y equals mx plus b. They mean the same thing. This is just called functional notation. In the context of the word problems, these numbers are where b is the initial value and m is the recurring value. And we'll talk about that a little bit more on later questions. So go ahead and flip over to page 116. All right, remember we worked this problem, but let's talk through it one more time so you feel comfortable with it. I know you already have the notes for this, but just double check. It doesn't hurt you to go back over it. So during the last swim meet, Jake dove 8 feet away from the starting point and swam away at a rate of 4 feet per second. Okay, so the independent variable in the context of this problem was the dependent. So this is feet, okay, and this is seconds. So for which value of the problem is the initial value B? So let's think about, he dove 8 feet away and he was going to swim at 4 feet per second. So this is how far he started from there when he dove in the pool, and then he swam that fast. Write a linear equation. So this is going to be y equals 4x plus 8. Okay, so they have it as d at t. Remember, this d at t, that's functional notation. It means the same thing as y. So we can put our equation straight down here. Because they're using t, this would actually be a t value. This could be an x value, so that's an x value. Whatever this value is, this value will also be. So how far will he be after 8 seconds? So that means, what is d at 8? And that's going to be 4. There was a t there, but now we have 8 going there. So 4 times 8 is 32 plus 8. So this is going to give me 40. So he is 40 feet away. That's how far he swam, 40 feet. Not down, just across the lake or something. How long will it take him to be 100 feet away? Well, in this case, I'm going to take the 100. I'm going to go back to my equation here. And the 100 is going to go in for d at t. It's going to replace it. So let's solve for t. So subtract 8 from both sides. That's going to give me 92 equals 4t. Divide both sides by 4. So t is going to be equal to, if you go 92 divided by 4 on your calculator, comes out to 23. So for him to be 100 feet away, it would have taken him 23 seconds of swimming in the pool or the lake. Jake's race will end after 2 minutes. How many seconds is this? Okay, 2 minutes. Remember, there are 60 seconds. So this means this is going to be 120 seconds. So we want to know how far Jake would have went. What I'm going to do is I'm going to take the 120 and plug it in here. So I'm going to get 4. There was a t there, plus 8. And I'm going to plug 120 in there. So that's going to be 4 times 120 is 480 plus 8. So if I add those together, he is 488 feet away. So it must be a big lake he's swimming across. That's truly farther than a swimming pool. The domain and range, let's not worry about these too much. It's just a little bit much to really fathom it. All right. So we've done quite a bit of this. So let's take a look at this. Let's say that this is a point down here. So that point down there is -1, 2, -3, -10, 11, 12, 13, 14, -3, -14. And then this point up here is -1, 5. This point right here is -2, 0. This point right here is 0, 0. This point right here, let's just say that it's right exact. So that's going to be 2, 2, -8. And then this point right here looks to be 3, 0. All right, we're going to go ahead and do this problem. Now, we don't have an equation, so what we want to do, f at 2, or -2. So I'm going to go -1, -2. -2 gives me 0 for an answer. That's why the point -2, 0 exists. If I take this point, f at 0, right here, that's what's happening right there, which the y value is 0, 0. So this is going to yield me the point 0, comma 0. All right, let's change some more colors. Let's go to an orange. So f at 3. So I'm going to go right 3. I'm going to go right to that point. What is the y value? It happens to be 0. So this gives me the point 3, comma 0. And we're just going to make some more colors. Let's go for the nice pink color. F at -3. -3 is -1, -2, -3. Come all the way down here. Oh, look what happens. That gives me -14. So that gives me the point -3, comma -14. What about this one? -1. If I go back -1, that goes right up to here. So that's going to give me 5. So this would have been the point -1, comma 5. And let's do that one. If I go to 1, if I go over 1, oh, this one's a little tougher to see. It looks like it's taking place right there. So that looks like it's down -1, -2, -3, -4, -5, -6. So that's -6. So that gives me this as my point. So this next problem, we want to talk about where our graph is increasing. So it's increasing as I go to the right, and it's going up. So here's increasing here, and here is also increasing. So I am going to use the x values. So this to this is one of the intervals. So -3 to -1. This is not a point. This is an interval. That's where it's increasing. It's also increasing from 2 to 3. Make sure you, if you have any questions, you ask me, and raise your hand, I'll come over and talk to you. This is where it's decreasing. Okay, so as I go to the right, it goes down. So when it's decreasing, I'm going to use this x value and this x value. So it goes from -1 to 2. And a lot of things that people are struggling on is where is this positive? So the decreasing was the blue. I'm going to do pink for the positive. Positive means it's above the x-axis. So if you take a look at that region, okay, using the x letters, where is it positive? Well, it's positive from here to here. So from -2 to 0. So what I would like to do, and you might have to use your phones to translate, is I'm going to have the class work on page 117 and page 118, all the problems. Okay, so if you need help translating, utilize your phone or ask one of the other students who speaks English and Spanish to help you out. But that's what we're going to work on. If you get it done before the class period's over, you don't have homework for the weekend. Have a nice day.